Hello and welcome to Chapter 6, Section 1. We are solving systems of equations by graphing. Now, a system of linear equations is a set of two or more linear equations containing two or more variables. We're going to just be working with two variable equations, and most of them will have x and y in it. And when we come up with a solution, that solution will be an ordered pair that satisfies both equations. So, your first set of questions asks you to tell whether the ordered pair is a solution to the system. They're giving you two equations and they're giving you a point and they're asking you if it works for both equations. So you're going to plug that x and y into both of the equations to make sure that both are true. For example, we have the point 4, 1. And we have these two equations. So what we're going to do is plug in 4 and 1 for both x and y to make sure that they work. So here 4 plus 2 times 1 is 2 equals 6. That works. And 4 minus 1 equals 3. That works. And this is how you show your work in this kind of equation set. The next one, negative 1 and 2, and I'm sorry these are so crammed. 2 times x is negative 2 plus 5 times y is 10 equals 8. That one works. 3 times negative 1 is negative 3. And 2 times 2 is 4 equals 5. Negative 3 minus 4 does not equal 5. So this point does not work for this system. Why don't you go ahead and give this a try? Check it out, numbers 1a and 1b on the bottom of page 397. Pause the video here and come back when you've tried it. For 1a, we plugged 1 and 3 in, and the first one works and the second one works, so that one is fine. For 1b, we've plugged in 2 and negative 1. This one works, but this one does not, so this is not a solution for this system. The next section asks you to find your solutions to linear equations on a graph. And what we're doing is we're graphing both of the lines, and where the two lines meet, usually this is in one point, and that's the solution. The ordered pair that you're looking for is that one point. So when it asks you to solve each system by graphing, it wants you to find the exact point where the lines cross. Now, this works well if you have an easy slope in the real world, but in the real world, this isn't very often a great answer. However, the ones they're going to give you when they specifically ask you to do this should be easy enough to see if you use graph paper. Now, unfortunately, I don't have graph paper, so my lines are a little wavy. So we're going to start with two equations that are already in slope-intercept form, so I can graph them easily. Here I'm going to start with negative 3, and my slope is 1, which is 1 over 1, rise over run. So I'm going to go up 1 and over 1, up 1 and over 1, up 1 and over 1, and my first line is about here. My second line starts at negative 1 on the y-axis, and it's going to go, this is actually negative 1 over 1. It's going to go down 1 and over 1, down 1 and over 1, and that point is here. And so here it's easy enough to see that where these two lines cross is at negative 1 comma, nope, 1 comma negative 2. Okay? Let's try another one. Here we have x plus y equals 0 and y equals negative 1/2 x plus 1. Now we want both of them to be in slope-intercept form so that we can graph it easily. So we're going to do subtract x from both sides, and y equals negative x plus 0. So here we're going to start at 0, 0, our y-intercept, and we're going to go down 1 and over 1, down 1 and over 1, down 1 and over 1, and we're going to end up with this diagonal line right through here. And then we have y equals negative 1/2 x plus 1. So we're going to start at the 1, and we're going to go down 1 and over 2, down 1 and over 2, down 1 and over 2. And this isn't going to get us across that line at all. So we're going to go this way, because that and that mean the same thing. We're going to go up 1 and over 2, and check that out. That is probably where our lines cross, because they're going to make it easy on us. And that is going to be negative 2 over and 2 up. That's going to be point negative 2, 2. And if you check this in one of these, you can check to see if your answer is correct. And we've got a really easy one to check. We can say negative 2 plus 2 equals 0. Yes, that's a good solution for that. Your job now is to try solving a system of equations by graphing. The bottom of page 398, check it out, numbers 2a and 2b. Give it a shot. Pause here and come back when you're done. Okay, for 2a we have two equations that are already in slope-intercept form, and I've graphed these in purple, and they seem to meet at negative 2 comma 3. And I've checked both of them. I put negative 2 and 3 in both of these to make sure that that works and they're both correct. For B, I have two equations, and this one's not in slope-intercept form, so I can make it in slope-intercept form relatively quickly. I graphed them both in red, and they seem to meet at 0.3 comma negative 2, and I stuck 3 and negative 2 in for x and y, and they both work. Now we're going to try a word problem. On page 399, we're going to the Bowl-O-Rama, and that charges $2.50 per game, and with a $2 shoe rental. And the Bowling Pins charges $2 per game and $4 for shoe rental. And the question is, at what point do they cost the same? And what is that cost? So, anytime you have price per game, the per means times x. And the total cost is always going to be y. So you've got two equations, the total cost, price per game times the number of games, plus the one-time rental. Anytime you've got a one-time fee, that's going to be your plus at the end. So here I've got my two, and we're going to graph these. So we're just using the quadrant 1 because you can't have a negative cost and you can't have a negative number of games. So we're going to start at the 2, and we're going to go up 2.5 and over 1, and 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 we're about there. And then we have this one where we're going to start at the 4, and we're going to go up 2 and over 1, 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 up 2 over, let's see, and this is where graph paper would be really awesome because I'm just not sure where this crosses this line. So let's guess that it crosses 1, 2, 3, 4 over, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up. Let's see how we did here. So 12 equals 2.5 times 4, which is 10, plus 2, that works, and 12 equals 2 times 4, which is 8, plus 4, that works. Okay, so there's our answer. Please get graph paper because this is a pain in the neck without it. Try the check it out, number 3 on the bottom of page 399. Pause the video here, give it a shot, come back when you're done. And for number 3, we have our 2 equations that build our system, and we graphed both lines, and it's somewhere around here, and so we guessed 5 out, and I didn't follow my graph very well, but 5 and 25 are your answers for that. Okay? This is a pain in the neck way to solve these. This is the only time you have to solve them this way. Sometimes it's actually easier, particularly when you've got graph paper just hanging around. So if you can do that, your world is much better. Your homework starts on page 400. You're going to do numbers 9 to 25, but not 19 to 22. That's the one that asks for a graphing calculator. Okay? Good luck, have fun, and please ask if you have any questions. The following video will walk you through the word problems if you need help with any of those. Okay? Thanks.